Good afternoon, myself Rakesh, and I am here to present my internship project EV ADAS dashboard system developed using STM32, PiximLab, and Python dashboard. And the main aim of the project is to build a real-time EV ADAS Python dashboard system. Modern electronic vehicles generate large amount of data such as speed, battery, SOC, and the battery health and all this temperature safety information. So this combines the vehicle's elementary and ADAS features into a single dashboard. Firstly, during these 14 days, we had learned many things like configuring the dashboard to the terminals and UARTs, LEDs, buzzers, implementation of the sensors, and reading the accelerator and brake readings in a particular EV logic systems for the torque, SOC range, and drive. And modes and builds the ADAS features such as following the collision warning. This blindly detects blind spot detection. That means if any vehicle is present near our vehicle in our surroundings using ultrasonic sensors, and we can see the speed history in the Python dashboard. Like this, of all full management has been developed in a single Python dashboard. Firstly, we will see what EV dashboard matters. Why EV dashboard matters? Because in this era of the electronic vehicles, the state and the health of the vehicle, like is the battery is drained, or the speed is over related, or if any vehicle is approaching us, or we are ahead to the any vehicle, it will give us information and detects the alarm and makes the driver and passengers to be safe. So to develop this Python dashboard, the main things are real-time speed, SOC, and range monitoring. And the coming to the requirements of the project and the objectives, the real vehicle telemetry, it continuously monitors the accelerations, brakes, and temperature, and speed, torque, and range. By maintaining this data, it can it can detect the faults in the faults in the vehicle and presents it on the dashboard. And collision and blind spot detection, like if any vehicle is occurring approaching us, or we are moving at nearest to the vehicle, the ultrasonic sensors will be reacting and sends the alert messages to the dashboard, and we can implement like automatic braking systems or line adjusting management like that. And we had given that the fault detection and alarm escalations, like the alarm will be turned on when we are approaching the danger, like that we had developed many. And coming to the tools, we had been used like STM32 Cube ideally, PiximLab. The STM32 Cube ideally is the IDE for STM32 microcontroller, and PiximLab is like it's a simulator lab. And we had used the Python to show the dashboard in the display of the electronic vehicles. And we had included many libraries like matplotlib, numpy, and pyserial. So these are the tools we are required to the software stack. And hardware components we can see in the spare parts of the Pixim lab, like STM32, three ultrasonic sensors, and LEDs, and USARTs, and potentiometers. So like that we had been implemented the hardware components in the spare parts for this project. And coming to the system architecture total overview, the sensor detects the approach and sends the data to the microcontroller. The microcontroller sends the data to the UART, like the virtual terminals, and it after taking the data, and it gives to the Python dashboard. In this journey, of 14 days or take. Like we had been made many projects like LED blinking, ultrasonic tests, and attended 3 quizzes, and also made the main project like developing an Python ADAS system. This internship journey has came like at starting days we had set up the tools and all GPIO input and output pins. At second and third and fifth days we had practiced on how the sensors and how to add the and how to use the tool properly. And at day 6 and 8 we had been used the ultrasonics and alarms detection systems to implement and submit like a mini project. At another days we had used it as a time interrupts and all this. By learning in the each video we had came through across how to use the tool and how to apply the real life situations. And at lastly we had designed the Python dashboard, and we had gone through the results and demo and testing the Python dashboard continuously. Like we had seen at the day 1 and day 2 all the softwares installed, and at day 3 and day 5 we had tested the potentiometers and the ADC sensor systems, and at 6 and 8 the ultrasonic system faults and made a mini project on the ultrasonic systems. And at day 9 and 10 we had been used all the speed, SOC, torque, temperature, range, accelerator and brake. All this has been used. And finally, we had implemented the Python dashboard successfully, which shows the Python speed, which shows the vehicle speed history, vehicle speedometer, and torque, accelerator, brake, and how much range it acts. And we had given the bird view cam that we are approaching a vehicle, how many centimeters or how much distance we are ahead to it. And it finally we had learned how to build an Python dashboard using STM32 microcontroller and using the simulators. And also we had been used some VSAPs to create some virtual serial ports, and also used the cams to tetratom to see the virtual terminals. Now let us see our project, like how it works. At first we had created an EV dash folders and we had included some libraries. In that we had created some header files and also the source files. So in this mainly we can go through it is main.c. Like firstly we had all included all the libraries and the header files, so that all the files are being included in this. And we had been implemented the time handle definite type. In each and every file we had defined the function and calling it in the main.c. So in the each and every loop and each and every sentence we had defined that what should be displayed, and we had been written some codes like this that calculates the speed, torque and temperature range, and what is the acceleration, all this. So we had been using these kind of formulas to calculate the speeds and these parameters. So here we had seen that oscillation types and many of the clock speeds, and also we had been used all these header files to create. Each and every file is important to control the Python dashboard. We had also made that the error handlings, that if anything occurs to the near to the far, and if anything occurs the LEDs must be blinking and should give the alert messages. So this is the kind that the we had in the EV dashboard. And this is the IOC, where it is a microcontroller chip pin settings. We had set up the pins like this and called it in the spare parts. in the Pixim lab. So here you can see that we had assigned the pin values like PA0, PA1, PA2 and PA3 for one purpose, and PB0s for one purpose, PA10 to PA8 for one purpose. Like every pin has been defined for its own purpose. Now let us see the simulations. Like when we open the Pixim lab, it will be shown. We had to set the IO to 8 for 8 megahertz and 31 to 31.25 MIPS. So while we enter to this, we can see the microcontroller chip name STM32F103C8T6. So the main part of this simulation is the spare parts. Yeah, here we can see that the spare parts. This is the potentiometer, and this is the ultrasonic sensor, front, left, and right. And this is the transmitter and receiver, which shows the virtual terminal. And this goes for the LED, and this is the buzzer. So when we want to see the virtual terminal related things, we can click on here. Here we can see the readings like front distance is 400, left is 99, and right is some triple two centimeters distance. And we can see the collision all BSD. After some certain calculations, it will be giving the status of the condition status of the EV vehicle. So here we can see the speed is 16.3, 18.5, like it is increasing rapidly. Like we can say that we have the full control of the system. Like when we increase the speed, it doesn't like rush it in a single time. It takes the speed constantly. So if I increase the speed and increase the PA3 pin and decrease the ultrasonic sensor, we can see the alert messages. So we can conclude that like we are approaching a vehicle and to be set to alert. So this is the simulator which had been used. By clicking reset, we will be resetting all the battery values. So when we want to run the Python dashboard, we can open the command prompt. Like I had been saved my files, EV dashboard. This is the file which had been seen there. So this is the main Python file which shows the dashboard of the uh, project. So let's copy the path and let's press Windows R, CMD. This opens the command prompt. After opening, we will be moving into the E drive. Yeah, we had entered into the E drive. In that, we will move into the our directory by pressing the CD. So now here we can call the function like or call the file like python space ev underscore dash dot py space hyphen hyphen port space com1. So we had been using the com1, like we had already paired in the virtual serial port emulators. Like we had already paired the com1 and com2, which helps in interlinking the ports between the teraterm files and the VSP32 VSPE. So same as the Pixim lab, it displays the output while having like this. I will show you a while. Like we had to configure com2 save. Now we will open the Terraterm serial host. Okay. Now the Pixim lab and the Terraterm virtual terminal has linked to each other by using the COM portals. The COM VSP creates the temporary COM ports in the device manager. So we can see the all the status here. So if we want to run the our dashboard and see the dashboard, we had to give the Python file name and hyphen hyphen port and port number. I had been using here port com1, so I had been called it. By pressing enter, we can see that the opening of the Python dashboard. Yeah, here we can see that we can see the speed. The meter will be like an analog meter that we can see, and here we can have the battery life and how much km it can be moved using this having battery. You can see the speed history here, and the acceleration is 100%, torque is 0, and the temperature is 115 degrees Celsius, 8 point Celsius. So this is the main attraction point of our project. Like ADAS bird view point, we had been said that EV is our vehicle. So at left side we had placed an ultrasonic sensor, right side we had placed an ultrasonic sensor, and this is like a bird eye view. At left side, the sensors works and detects the object if it is near. So let's take a trial in the simulator lab. I had been using, so the speed will be increasing constantly here, and the speed history will be taking care of the history. Like when we are using the following characteristics, like battery will be drained. So if we reduce the ultrasonic distance, it gives a alarm critical. So the distance depends on the parameter that we are following. So if I increase, the distance will be far away from the opposite vehicle, and the alarm sets to the none. So this makes a lot of difference in preventing the accidents and having an front eye to detect the before accidents. At the conclusion, I will be declaring that the development of this Python EV dashboard gives us a really good experience in having an embedded systems, and the EV is a future of the of the vehicles in the world, because due to the pollution made by the uh, in petrol vehicles and petroleum vehicles and diesel vehicles. So developing an EV ADAS dashboard, lots of knowledge is gained. Thank you.